In this video, I am introducing the concept of critical values. So a critical value occurs in one of two places, either where the first derivative is equal to 0 or where the first derivative is undefined. So let's take a look at an example. In this first example, first thing we need to do is find the first derivative. So the first derivative will be 6x minus 12. So the easiest thing to do is look to see where the derivative is undefined. Well, in this particular case, the first derivative will be defined everywhere. To know where it's going to be undefined means we have to have division by 0, okay? Division by 0. If you're going to have division by 0, then it is undefined at that point. There is no division here, so there's no division by 0. So the next thing to do is to look to see where the first derivative is equal to 0. So we simply take this, set it equal to 0. So then we have 6x equals 12, or x equals 2. 2 is the critical value. We have one critical value at x equals 2. And that's all there is to it. In the next example, let's once again start by finding the first derivative. So f prime of x is going to be equal to 6x squared minus 24. Once again, there is no division by 0, so it is defined everywhere. That is to say, there's no point where it is undefined. So let's set it equal to 0. And so we have 6x squared equals 24. X squared equals 4. Taking the square root of both sides, we get x is equal to plus or minus 2, because we have to account for the positive and the negative square root. So we have two critical points, or two critical values, at x equals 2 and x equals negative 2. In the next example, fairly similar. The first derivative is 12x cubed minus 12x squared. There's no division by 0, so there's no place where the first derivative is undefined. We can set it equal to 0. And so to solve this, the first thing we want to do is factor out the common factor of 12x squared. That will leave me with x minus 1 equals 0. We then set both factors equal to 0. And so we get x is equal to 0 and x is equal to 1. So we have two critical points, or two critical values at 1 and 0. In this problem, the algebra is just going to be a little bit more difficult. So finding the first derivative, we're going to have, let's see, 6 times 2/3 is 12 divided by 3 is 4. X to the negative 1/3 minus 30x. Now, what about division by 0? Well, keep in mind that this is really 4 over the cube root of x minus 30x. So we will have division by 0 because we have an x in the denominator. And so when x is equal to 0, f prime of x is undefined. So that is a critical value. We now need to find any other critical values. So let's take this and set it equal to 0. So 4x to the negative 1/3 minus 30x equals 0. And we need to factor out, we can factor out a 2, and the lowest power of x is x to the negative 1/3. And so we will be left with a 2 minus 15x to the 4/3 equals 0. Here, setting this equal to 0, we get 2 over the cube root of x equals 0, or 2 equals 0, which gives us nothing. And let me move off to the right here. Here we have 2 equals 15x to the 4/3, or 2/15 equals x to the 4/3, raising both sides of this to the reciprocal power, which is the 3/4 power. We will end up with x is equal to 2/15 to the 3/4 power, which is going to give us two answers, and those will be decimal answers. And I will leave it to you to calculate what those are, but there will be two critical points here, and there will be one critical point where it was undefined, so we have a total of 3 critical points for this particular problem. 3 critical points at 0, and then plus or minus, I think it's about 0.221, plus or minus 0.221 when we calculate 2/15 to the 3/4 power. All right, the next problem, we have a radical. So we haven't done one with a radical yet. Let's take the derivative. So the derivative, f prime of x, first of all, you may want to change this to 8x to the 1/2 power. And so this is going to be 1/2 times 8 is 4x to the negative 1/2, which of course is 4 over the square root of x. So x equals 0 is undefined. So that is a critical point. That's one of our critical points. Where else are we going to have a critical point? Well, when we set this equal to 0, we end up with 4 equals 0, which gives us nothing. So we have one critical point at x equals 0. One critical point or value at x equals 0. And one more. So this is very similar. You may want to change this to 4 times x minus 2 to the 1/2 power. The derivative is then going to be 2 times x minus 2 to the negative 1/2 power. And then we have to use the chain rule, but the derivative of x minus 2 is just 1. And so this becomes 2 over the square root of x minus 2. So if we set this equal to 0, we get 2 equals 0, which gives us nothing. However, we have an x in the denominator, and what value of x will cause us to have division by 0? Well, that would be x equals 2. If x is equal to 2, we get 2 minus 2, which is 0. The square root of 0 is 0. So we have one critical point, or one critical value, at x equals 2. So that's finding critical values of a function.